Scientists have different theories about how the solar system began, but the most popular theory of all is the Big Bang theory, where with an explosion, all the planets were formed, and that's how the solar system existed.
Our Sun formed about 4.5 billion years ago in the Milky Way galaxy's Orion Spur. It was born when a cloud of dust and gas, known as a solar nebula, collapsed. And in the middle of this formation, matter condensed into a burning ball of gas that became our Sun. The Sun can be divided into 6 layers or regions: the corona, the chromosphere, the photosphere, the convective and radiative zones, and the core. Our Sun is the largest and most massive object in the solar system. It's more than 100 Earths wide and could theoretically fit all 8 planets inside nearly 600 times. Mercury is the smallest planet in our solar system. Its diameter currently measures just over 3,000 miles, about the size of the continental United States. Like Earth, Mercury is a terrestrial planet with 3 main layers: a core, a mantle, and a crust. Only Mercury's crust has no tectonic plates. Because of the core's exceptional size, it's had a surprising influence on Mercury's overall size by causing it to shrink. Venus, the second planet from the Sun, is very similar to Earth from a distance, but up close, it's a very different world. Venus is about the same size as Earth, just slightly smaller. Its structure is also nearly identical, with an iron core, a hot mantle, and a rocky crust. The crust of Venus, however, is dotted with thousands of volcanoes, including Maxwell Montes, a volcano almost as tall as Mount Everest. Venus also has a thick, layered atmosphere. It's full of clouds that rain sulfuric acid and whip around the planet at speeds up to 224 miles per hour, faster than some Category 5 hurricanes. The atmosphere is so thick that it creates a surface pressure similar to what it would be about half a mile deep in the Earth's oceans. This pressure is heavy enough that a human standing on Venus's surface would be crushed. The atmosphere is made of greenhouse gases, primarily carbon dioxide, which create an extreme case of global warming. They trap the sun's heat, causing surface temperatures to rise over 880 degrees Fahrenheit, making Venus the hottest planet in the solar system. Venus is so inhospitable, neither humans nor spacecraft are able to survive the planet's surface. But some scientists speculate that Venus wasn't always so unwelcoming. From roughly 2.9 billion to 715 million years ago, global temperatures on Venus may have been just a few degrees cooler than Earth's are today. And scientists theorize that the surface may have contained shallow oceans that could have held enough water to support life. Earth, the only planet known to maintain life, a product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants. but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. The story of Mars began about 4.5 billion years ago when gas and dust swirled together to form the fourth planet from the Sun. Mars is the second smallest planet in the solar system, with a diameter just shy of the width of Africa. In fact, its entire surface area is similar to that of all of Earth's continents combined. Much like its terrestrial cousin, Mars is dense and has a rocky composition. At the center of the planet is a core made of iron, nickel, and sulfur, which may have created a protective magnetic field during Mars's earlier years. Enveloping the core is a rocky mantle made of silicate minerals and a crust rich in iron. These iron minerals react with the trace amounts of oxygen in Mars's atmosphere and rusts, giving the planet its signature reddish hue. Today, Mars is dry, desolate, and cold, with temperatures dropping as low as -225 degrees Fahrenheit. But billions of years ago, the planet was much warmer, more geologically active, and had a watery surface. Lake beds and river valleys snake along the face of Mars, indicating that liquid water was, for a time, present. Volcanoes, such as Olympus Mons, the largest volcano in the solar system at 3 times the height of Mount Everest, once erupted lava. But by about 50 million years ago, soon after Earth's dinosaurs died out, Mars's volcanoes also went extinct. Water on the red planet still exists today, but mostly in the form of polar ice caps. Jupiter is the 5th planet from the Sun and the largest planet in the solar system. At approximately 11 Earths wide, Jupiter has twice the amount of mass as the other planets put together. But unlike Earth and the 3 other terrestrial worlds, Jupiter has no solid surface. It may not even have a traditionally solid core. Rather, this giant planet may have a dense liquid center surrounded by a worldwide ocean of hydrogen and helium gases. Jupiter's gaseous composition can be observed in its atmosphere. About 44 miles thick, the atmosphere is a canvas of stripes and storms churning across the giant planet. Their colors range between shades of whites, yellows, browns, and reds, all caused by the different chemical makeup of each area. Probably the most iconic feature of Jupiter is a crimson-brown storm that's been raging for over 300 years. The Great Red Spot. It's a giant swirling collection of clouds with wind speeds of up to 400 miles per hour, at least 2.5 times faster than Category 5 hurricanes. Floating hundreds of miles above the storms of Jupiter are about 79 moons, the most of the 8 known planets. In the solar system's earliest days, Jupiter, being the first planet to form, attracted and destroyed space debris that would have helped the other planets grow in size. Today, that force may serve as a shield by attracting comets and asteroids onto Jupiter's own surface, preventing them from crashing onto inner planets like Earth. Saturn is the second largest of the 8 planets, and it is about 10 times as wide as Earth. Despite its size, Saturn is actually the lightest planet. It is predominantly made of the gases hydrogen and helium, and because of its particular gaseous composition, Saturn is the only planet in the solar system that's less dense than water. If the planet were placed on an enormous ocean, it would be able to float. Saturn's gaseous makeup also means that it has no true surface. At its center, the planet has a dense core of water, ice, and rocky material, but it has no actual landmass. Because of Saturn's inhospitable environment, the planet cannot support life, but some of its moons might. Saturn has more than 50 confirmed moons, and each varies in size and terrain. Saturn's ring system is the largest and most complex in the entire solar system. The rings are made of icy and rocky remnants from comets, asteroids, and moons. The particles range in size from being as small as dust to as big as mountains. The ring system is divided into 7 groups of rings. Altogether, they are as wide as 4.5 Earths, but only about 2/3 of a mile thick. How the rings are able to stay on track and intact has to do with Saturn's smallest moons. Called shepherding moons, these tiny satellites orbit between the rings, and they seem to use their gravity to shape the ring material into circular paths. Uranus is the 7th planet from the Sun. From a distance of about 20 astronomical units, or 20 times the distance between Earth and the Sun, Uranus orbits the star once every 84 Earth years, approximately the length of a human's entire life. This orbit causes each season of Uranus to last that much longer. Theoretically, a human living on Uranus would experience the 4 seasons only once, but each for about 21 years. Partially due to its distance from the Sun, Uranus boasts the coldest temperatures in the solar system. These icy temperatures, dropping as low as -370 degrees Fahrenheit, are largely influenced by the planet's composition. At about 4 Earths wide, Uranus has an Earth-sized core made of iron and magnesium silicate. The remainder, approximately 80% of Uranus, is a worldwide ocean of ices made of water, ammonia, and methane, the chemical behind the planet's cool blue color. This icy composition prevents Uranus from emitting much heat compared to other planets, making the blue world the solar system's coldest. In addition to its extreme temperatures and orbit, Uranus has a dramatic orientation. While the other 7 planets spin on their axes like tops, Uranus appears to roll along its equator. The planet is tilted at a near right angle, in which polar regions point toward and away from the Sun rather than upward and downward. This tilt, thought to be the result of Uranus's collision with at least one celestial body, has also affected the orientation of Uranus's 13 rings and 27 known moons. Unlike the rings and moons of other worlds, which orbit their home planets horizontally, those of Uranus orbit in a vertical orientation along the planet's tilted equator, much like a... Neptune is the 8th planet from the Sun. At about 30 times the distance between our star and the Earth, or 30 astronomical units, Neptune is the most distant planet in our solar system. This distance creates the longest orbit of the 8 worlds, about 165 years, with the seasons lasting a little over 40 Earth years each. Being so far away from the heat and light of the Sun, Neptune is cold, dark, and icy. At its heart is a solid core about 1.5 times the size of Earth. Making up about 45% of the planet's mass, the core is made of water ice and silicate rock. The rest of the planet is believed to be a hot, pressurized ocean of water, methane, and ammonia ices surrounded by a layer of clouds. These clouds, predominantly made of hydrogen and helium, include traces of methane, which give this ocean world its rich blue color. While the clouds create a cool, calm veneer from afar, up close they are whipped around by the most severe weather in the solar system. Winds on the planet reach speeds of over 1,200 miles per hour, nearly 5 times faster than the strongest winds recorded on Earth. In fact, the winds are so powerful that they break the sound barrier. Drifting high above this windy ice giant is a quiet ecosystem of rings and satellites. 6 rings encircle the planet, with some containing ring arcs, or clusters of dust particles in a ring. Also revolving around the planet are 14 known moons. Much is left to be discovered about Neptune, its rings, and its moons. Only one spacecraft, Voyager 2, has visited these cosmic bodies, but future missions to this mysterious, icy world would have even more stories to tell.